Day 18, simple VHF receiver. This is a super-regenerative receiver for about 76 to 160 megahertz as built. It's still work in progress, but the receiver is already useful. I hope to bring a few future videos covering the audio amplifier and filter for it, and maybe a noise squash, which makes the receiver much more comfortable to use. I built it mainly for the airband. The airband uses AM, so I think 108 megahertz just above the FM broadcast band to 137 megahertz. The bottom 10 megs or so are generally beacons, and then above that you'll have voice and some data. At work I recently got interested in the around the 1 gigahertz region. There's some digital data and radar information systems for aircraft that I've been playing around with detecting. Something that it's a lot more work than simple audio like this, but I've already built antennas for that frequency, including a Yagi that works quite well. I was pointing it at individual aircraft and seeing the signal improvement. This has got about 9 dB of gain as designed. When I finish it, I'll write up the documentation. But this has very little to do with this project, but it's essentially the lead into it, because where I work, we sit under a glide path, and there's always a lot of aircraft flying around, and see them going in and out, and get on the net and find out what they are. And I was interested in how the systems on the net actually work, and that got me interested in the whole trying to work out how to do that myself. But anyway, this is a much simpler project that you can build. Being VHF rather than microwave, it's much simpler to actually construct and get working. You can build it dead bug and it'll probably just work. So there's a antenna buffer here to stop signal basically leaking out backwards into the antenna, which just causes noise interference for everyone else. Also has a bit of gain, so amplifies signals, improves the noise figure of the receiver. It's quite sensitive, probably more sensitive than you'd actually need. Off-air signals, it can hear just about every FM broadcast station, and it can hear the approach controller and aircraft, etc. on the airband. The receiver's very common oscillator that you've probably seen me use before. This particular choke I haven't labelled here because I haven't measured it yet, but it's 8 turns on a ferrite bead. It's just basically an RFC to keep the RF from getting shunted by this capacitor here. Yeah, normal common base oscillator. This is a little red trim cap, and this is a 90-ish nanohenry inductor. Just a little air coil. I think it's 5 turns. And this is 7 turns. It's 150 nanohenry. I measured them using my nanohenry impedance bridge, which we have here. It's well, the details are on my website. It's actually a project from someone else. It's very useful, and you might want to build one. As you can see, it goes from about 75 nanohenries up to about 800 nanohenries. It's quick and easy to use. You just shove the coil in the antenna, the connectors here, which are normal speaker terminals. It's not particularly accurate, but it's good enough to get you in the right ballpark. Particularly good for VHF projects. I recommend you build one anyway. Details are on my website. I'll probably post a link. But that's, again, not what this video is about. Alrighty, without further ado, here's the actual receiver as built so far. That's a beetroot tin lid. This is a trick that I learnt from Burkhard. He does a lot of projects on, I think it's a kind of coffee tin lid that he uses, or base. But tin plate is enormously useful because you can solder to it quite easily, and it's pretty commonly available. Cans are essentially a waste product. This particular can has a little bit of a coating on it, and you have to scrub it off with some steel wool. But once you get there are some cans that are even better than that. There's a particular malted chocolate drink that comes in an uncoated can, or at least the outside of the can is uncoated, and it's very quick and easy to use for these kind of projects. Antenna wise, I actually built this antenna at work today. I took some wire in, twisted it up quickly based on a few calculations using a calculator on my website. It works quite well. It's fairly broadband. It's quite low impedance because it's a short antenna, so it's about 12 ohms at resonance. So I actually decreased this resistor here more than I had calculated to, originally I was running about 500 microamps through here to give a reasonable 50 ohm impedance, but I've dropped it down to, well, quite a bit more than that, and it gets fairly close. It's about 20 ohms maybe, so the return loss into here is not too bad. Again, it's not particularly critical. You can actually build the receiver completely without this stage and just have this, and couple an antenna to here or to here is probably safer, with a very small capacitor, and you'll get reasonable performance. But the antenna buffer is just a nice citizenly thing to do. Keeps from radiating the junk out of the super-regenerative stage back into the air, particularly if you're going to use it on the air band. I don't know how much interference it would actually cause to aircraft because there's not a heck of a lot of signal power here, but I can certainly detect the RF with my RF sniffer here, so if I get near it, it'll peg it. But you know, again, it's completely unshielded sitting here, but very little is going to radiate, and there's a huge difference in the amount of current that I see on the antenna versus the amount of current that I see here. Alrighty, I haven't built the audio amplifier and filter for it yet. I've got some ideas about that, and I also want to build a noise squelch, or perhaps a squelch based on the regeneration rate of the super-regen detector, which is kind of a log signal strength indication. That's probably going to be another video, and well, when I get around to it, I'll probably post an update video if it's not its own day. Alrighty, let's actually play with it. Again, following Burkhard's design here, I've put a shunt for the power connector, the jumper. Okay, so I'm just using the Archer amplified speaker because the Day 2 project speaker doesn't quite have enough gain yet. Okay, let's tune around a bit. So you can hear that whole region there is kind of the FM broadcast band. Then above it, in this kind of region up here, is the air band. A bit of noise there. And that is the carrier from a pager that's around here. It's about 149 megahertz. There's not a lot of modulation on it tonight because the paging system is fairly quiet at night. Similarly, the air band is quite quiet at the moment. During the day there's a lot more traffic on it, but seeing it's fairly late at night here at the moment, there isn't a heck of a lot of traffic for you to listen to. Again, I'll post some extra videos when I've got it all nicely set up. Power supply is just a 9-volt battery at the moment. It pulls, did pull a couple of milliamps before I fiddled with the resistor, but it probably pulls a little bit more now. It oscillates down to about 5 volts, and it works better off higher voltages just because of the way the circuit's laid out. And it's a JFET circuit. JFET's fairly need a fair bit of voltage unless you use special techniques, but I haven't really played around with the feedback. It might be possible to get it to oscillate at lower voltages with a bit of effort. Alrighty, that's about it for now. As you can see, it's already receiving signals off air. Like all super-regen receivers, it's pretty terrible for listening to wideband FM with stereo subcarriers. The quench frequency at the moment is approximately 40 kilohertz, which tends to harmonically mix with some of the stereo multiplex signals and sound awful, as you could hear when I was down on the FM broadcast band. So just go back down there for a minute. Actually doesn't sound that bad. I want to just pull the power supply. Alright, construction technique wise, pretty typical for VHF. Short leads wherever possible. I've actually gone fairly large for the inductors there, but this is just the audio signal tap off because I'm not completely happy with the values yet. The decoupling capacitors are pretty short. Yeah, that's really it. Not very difficult at all. You can just throw it together and it should work to some degree, and then you can work from there. Again, the inductor value is not particularly critical. I wound it on my screwdriver shank, which I think is about 8mm in diameter, inside diameter. The wire is I think it's 0.707, which is what, 22, 24 gauge, something like that, tin copper wire. I just stretch it a little bit to make it stiff before I wind it on the shank of the drill, or the shank of the screwdriver. Then I just shape it and cut it to length, solder it in. The JFETs are J310s, MPF 102s, BF 245s, even probably 2N5484s would probably work in this service. You might have to change the resistors in the sources to be appropriate for their IDSS and VPPs. I actually measured it to start with. I stuck one of the transistors in a solderless breadboard and put a pot in the source with the drain straight to the positive supply and through a current meter, i.e. the multimeter, and the gate grounded, and then I just adjusted it until I got, you know, a milliamp or two. Might talk about that briefly in a video too, about how to actually bias FETs. Biasing FETs and biasing BJTs is something I should probably cover, maybe not in the Advent series, but anyway, because it's interesting and everyone should know how to do it. It's not difficult, and it takes the mystery out of those values that you see in projects all over the place. You know, you wonder why they pick the particular resistor values they do to set up transistors. There's nothing magical about it. A little bit of math and some rules of thumb, and you're 90% of the way there, and the rest you can do either with simulators, you know, if you want to worry about the temperature stability of a circuit, or you can just build the practical circuit and test the heck out of it, which are probably what most people actually do. Alrighty, well, 12 minutes, I think that's long enough for tonight. Alrighty, till next time. Yep, keep the emails etc. coming in. I've got quite a lot of content for a viewer episode. Don't know quite what day we'll fit that in. I've got a list of things that I'd like to cover, and I'm actually starting to run out of days to cover them. So, of course, we can have projects any time of year. Advent is just an excuse, and no doubt there'll be more projects come out of this to talk about, you know, well into the new year. Alrighty, night.